So we're going to talk about decomposition and reliability of the model. We know when we do the prediction that we need to talk about whether that prediction would be reliable or not. And the thing is that when we make a prediction, we need to talk about the Holt-Winters model and the fact that it relies fairly heavily upon regular seasonal pattern and a regular trend. And if you've got those two components that are true, that they're both regular, then you can be fairly confident that your model is going to be a good model for making predictions. And you can look at this Holt-Winters graph and you can sort of see that it's mirroring the raw data reasonably well. There is some gaps, but nothing too major. And then you look at your decomposition and you work around to create percentages from the trend in the seasonal and the residuals. You look at the biggest component in the percentage of variation, and that happens to be, in this particular case, the seasonal component is the largest sources of variation. The smallest one is the residuals. And that's what you want in a reliable model. You want your residuals to be your lowest component of variation, that you're not getting a lot of random strange events happening over the data. And that seems to be the case here. So I would be reasonably confident in making a prediction with male deaths. But then we need to talk about what might be some random events that occur. I mean, what could cause this sort of noise that you're seeing here with regards to there's a fair bit of noise or randomness that's going on around 2005, 6, and 7. There's a lot of male deaths, and it seems to not a lot of noise in that there's a lot of variation between the model. That's what the residuals are showing us. It quiets down, and then there's a lot of noise around 2011 and so on. And we might be able to account for the 2011 anomalies between the model and the raw data by the earthquake in Christchurch might have caused the male deaths to spike, beyond what we might think that would happen. And what else could happen around male deaths? Maybe, there are medical interventions around heart disease or cancer or things that are causing male deaths that would then cause, a real blitz put on by the medical profession that would reduce male deaths and improve the overall health of males. Those are random events that a model can't predict. And so if you can go into the residuals and talk a little bit about something specific around some random events that could occur over time and could cause the model not to fit the data well, that would be good. And the fact that our residuals are our smallest component, that if we look at and we can look at the male deaths data. I mean, although there are some years not following exactly this pattern, most of the years have a peak in the second quarter and a trough in the fourth quarter, and then most of them are doing pretty much the same thing. Except for 2006, 5 or 6, this graph is pretty much steadily increasing over time. So I would say that we're pretty confident in making a prediction with regards to this. And so this is how you speak to this reliability and validity issue.